Hi Jürgen, welcome back.
Hi Adam, thanks for taking up with me again.
What I think today, I will always say yes, regardless what you are telling me, because I saw your Twitter avatar, your Twitter picture,
Mhm.
and it looks like you are hitting a poor guy with your feet, right?
No, I'm hitting the piece of wood he is holding over his head.
Ah, okay, because it looks like a lots of dust coming down to him, and he looks really scared. So, I think if you are now the chair of OSGI, it will be a great success because regardless what you are doing, no one will say no.
Yes, and I will beat everybody into submission who does not agree with me.
Very good. This
So,
is this is how you know how politics are working. So we need you, and then
yes,
everything is straight. Um, so
that's the plan.
what's martial art are you doing?
Taekwondo
Ah,
for
okay.
like 25 years now, and but it's so-called traditional Taekwondo, meaning we are doing it without contact. So not the Olympic version where you really have this full body protection and beat yourself up in free fights. This we don't
But
do. We
taekwondo
usually
without contact is like running without sweating, right?
yeah, you sweat a lot. No, it's more about body control. What
Hmm.
you're training there.
So there
So
is
it's not
no,
really
I
for.
mean, no body contact at all. I mean, how it in one time you have to do something right with the other guy, or
Yeah, this now we do this then with stones or wood, and
hey,
this is how we
this is
test it. So
a
from time to
corona
time,
safe,
I'm
right? Sport then.
yeah, exactly. So it's not really the 1.5 meters distance we have. It's more like a couple of centimeters.
Ah, okay.
We try to achieve. Yeah, but it's not really the main focus is not on self defense. It's more of train your body, train your
Okay.
soul. So
More
things
like
like that.
yoga. So,
So yes, a bit, yeah, like yoga, but you can use it for self-defense if push comes to
okay.
shove. So,
Which color of your belt do you have, if this is relevant for traditional taekwondo?
yeah, yeah, black belt, and we have this degrees for the black belts, and I have the second degree there
Okay.
for like 15 years now. So I have to, I'm kind of working towards doing my third degree for like 5 years now,
Okay. And what do you have to do
but I
to
just have
achieve the
to.
third one?
Basically, you have to find somebody who agrees to test you. So this
But
is
how you can
basically the
fight him
only
without
thing.
touching him?
Now, in this case, basically you show off that you understand what you are doing. You are showing it off by we have so-called we have a form of free fight. We have a form of demonstrations where you just show it close to your opponent, but yeah, you pull your punches basically all the time
Okay.
where you're doing it, and somebody else around it could say, hey, if you wanted it, this might have been a hit. So, and then you
Ah,
could
so you
get
need
points, for
good
example,
judges.
if you do. Yes, so it's usually a bit iffy doing it like this because sometimes like, okay, I wanted to hit. As if I wanted to really hit him, I would have. Please, why didn't you give me the point? But
Ah, okay.
yeah, this is not the main part. So we don't have that many tournaments where you really need to show off things like this. So you really do it more for yourself.
Yeah, interesting.
So, and it's really a healthy way to train your body because most of the things we are doing are also you can find in physiotherapy and things like this. So, because this is the way Taekwondo is doing its stuff, it's close to what karate does. It's really well defined for your body and your joints and everything, and it's really healthy actually. So,
Okay.
we have a really low risk of injury.
Okay. So now back to unhealthy OSGI, which
That's the
damages,
same thing with.
yeah, which damages your back because you have to deal with
Yeah,
modules.
I'm sitting all the time. Yeah, that's
Yeah, but uh, we get lots of feedback actually, or feedback, some reactions on Twitter about our discussion regarding modules and Java 9 modules and whatever. But I thought about how to deal with modules in the clouds because this should be topic for today.
hmm.
And from my perspective is if you listen what happens in the world right now, so people are talking about microservices, then Kubernetes and whatever. But the question is why, right? So why they are doing the stuff, and my impression is they would like to fight the complexity by
Hmm.
isolating, Java packages, let's say, to independent something. And because it works the best in their eyes, they distribute the system and have to use remote protocols to call, the microservices. And so they get lots of overhead, which means the entire system becomes more complex because now you have to deal with distributed, how to call it, distributed failures and inconsistencies and partial failures and distributed transactions and paxos maybe or sagas, which are like the how to call it, compensative transactions. So, but what the another direction could be, say, okay, I could isolate my stuff running on monolith, and inside the monolith, I can have my stuff, and this stuff is also isolated or somehow logically separated. And this is my observation right now, that we have actually two choices. We can run Kubernetes Kubernetes like container orchestrator. It doesn't have to be Kubernetes. It can be whatever, Docker Compose or whatever you have,
or whatever it is.
But or we can still remember that we are in the Java space, and we can have a nice application which is internally separated. So it's also the idea, your idea, or what's your thoughts on that?
My thoughts are basically whatever. I have the feeling there are two types of people. So the one that they are doing microservices because everybody is doing microservices. It's more like a cargo cult there. But so ignoring them, the most arguments I've seen for the current idea behind microservices is that it's more like, they want the advantages of modularity. So this encapsulation, and you can have different teams providing different services. You can have multiple versions and things like this. And the way Martin Fowler described microservices, with you have a Docker container with an API outside it, is basically the same. The picture for these kind of modules looks similar to what, for example, a bundle in OCI is defined. So you have these two boxes, your two services, and they communicate with services in between that are comprised of some kind of API. So they want to achieve the same thing, but by different means. And I believe the main thing came out of it because modularity, when you do it on JVM level, appears to be too complex. And when you do the OCI is a bit, for example, in the comparison, you have a lot of complexity in advance because you have to set all these things up. You have to understand what you're doing there, and the complexity does not grow as fast as in any other system over time. So this is the basic takeaway I've gotten from working with it for years. Doing the microservice approach, the couple of companies do right now. So everybody is developing its independent service in a Docker container, and this is you can do basically whatever you want in there. So which can yield quick results. And the complexity comes when you take these bigger containers and stick them together, because you have what you already mentioned. You have delays in between. You have a distributed system, and all the heap that comes along with this. There.
It's getting even worse, because if you think about this, if you would really go the container route, so to say a small, let's say, container services, what you will have one Docker container, but actually two, because you need some kind of failover. So you will need a load balancer up front with SSL certificate and DNS name, and you will always call the DNS load balancer. So it means, the other Docker services will have to know about the load balancer, and the traffic will flow through the load balancer to the Docker image. So I would say the real complexity is not about Docker, is around the infrastructure around like DNS name, SSL certificates, or TLS certificates, and security, of course, firewalls and security groups and stuff like that.
Yeah.
But if we have one monolith, let's say, we don't have it. So then we have one load balancer and two instances, and we are basically done. So I would say from the complexity and productivity perspective, it's great.
I think that's totally correct, because yes, you have some of the complexity like SSL and things like this. You have to take care of a monolith as well. But what I see when you have your microservice environment with something like Kubernetes, you place the load, the pressure on, which is usually on the application developer side. You just outsource it to your DevOps team, because how services speak with each other, how they are routed, how all these things work is usually something done inside your application in your monolith. And so you need to, as a developer, need to think about when you calling what, so how much pressure does this put on your internal service and things like this. So this is then the development team's job. And now it's more like, we just throw out this microservice, and the DevOps team will take care of it. Okay, so you just moved your internal logic to some external team.
Yeah, it's even worse, because in Kubernetes, my observation is the DevOps people are the developers, and what they always do, they use a kind of, I would say, template language to generate the Kubernetes deployment descriptors, which is, by the way worse than OSGI deployment descriptors. I'm not a huge fan of OSGI bundles, but I mean, I would rather do the OSGI bundle and generate them somehow with Maven before I write, the YAML in Kubernetes. And you can have Helm chart, which is very similar to JSPs, I would say. So something like this, which is not nice, I would say. Put it this way. Or some developers write their own generators. But still aside, whatever it is, there can be different reasons. Of course, some projects need to scale, which is complete different discussion. But from the modularity perspective, also interesting finding. In a recent project, there was a Whitefly project, and then you have to go to the cloud, and they had several microservices awards already. And we say, okay, we can pick just Fargate, it's easier than Kubernetes. And then they say, okay, then they wanted, to have one microservice per war, which would work, but we would get lots of tasks, and all the questions the challenges we mentioned right now would happen. And I asked them, it is a critical system. So if something breaks in a microservice, what is your process? Can you actually replace one microservice? Do you have a branch per microservice, or what's your internal structure? And it turned out that they are releasing everything at once anyway. So I say, okay, if you're releasing the entire application, what is actually the advantage to running multiple microservices which are potentially replaceable, but there is no process to replace them? And what we did then, we can have, it's hard to explain. So we have one node, physical node, with 5 Docker images on it, and they communicate via localhost. So there is, it's not like we going outside through the load balancer. Everything is in one thing, and there's the load balancer in between. So we have 2 tasks with 5 microservices, but the microservices are local to the machine. Very, very much like a pod in Kubernetes, which works well. There is no failover between microservices, but the idea is if something is wrong in one process, we get failover to another one, right? Of course, the microservices there are just there because they were there. It doesn't make any sense to have such a thing, Then the next thing would be to merge all the wars to one war, because why we should communicate via localhost, it doesn't make any sense.
Yes.
Yeah. But this is for historical reasons. What I wanted just to explain you, the expectation in the project was that we will run multiple microservices, and I asked some questions, and it didn't make any sense to have some microservices because
that's the cargo cult I was talking about.
Yeah. And in this particular, okay, we have Whitefly, there will be never OSGI because we have Whitefly, but the opposite would be, let's say, if we have OSGI, we could run, the very similar architecture without the wars. We have a thing which is called OSGI runtime or whatever, and we could put the modules, and potentially we could replace one version with another, if you like. And if not, we would be very productive with low complexity, because we don't have to deal with the infrastructure. And the infrastructure is, if you don't have Kubernetes, you still have to you have to think about the naming, the ports, how the services talk to each other. You have to deploy the Docker container first.
A lot of overhead comes around it.
Yeah. And you have to push the container first and then start the cluster. Otherwise, the cluster will wait. So there's a lot of operational complexity, I would say, you have to care about. And with OSGI, you could actually avoid it or reduce it to one app.
Yeah, let's an example of something that we did in the past, or we do from time to time. So we usually start with a monolith, or the so-called modulith or microservice monolith, however you want to call it. So we have our OCI modules inside our big application. And as they already follow the concept, the basic idea and concepts behind modularity in general, you already work with independent parts that communicate via services. These services are dynamic, which means you always need to, even if they actually don't in reality, but you can always see them emerging and going away, especially in your development process. So I've told you before, I develop something, I save my piece of code, so the jar gets redeployed and my service goes away, my service comes back. So while you are developing, you basically kind of start bulletproofing your application already for that's if something fails. So at least in the sense that everything has a decent, graceful shutdown when something goes away and not simply crashes and produces exceptions. So which means in the end, yes, when you always accept that everything needs to be there in order to work, then things are simply not there, but you have nothing which can produce errors. So, but you already have the mindset that things are not necessarily be there all the time. So then over time, your application grows, and you have something like, I would say, a user service, which on every login asks for the user and does some interaction with your data model. And that is, and your monolith grows and grows and grows. And at a certain point, you realize, and now it would be great. Also, this one component has really heavy load, so it would be great to have a second instance to split the load for this specific part or whatever it is there. And then you can take out this one component, move this to a different container with load balancing and whatever you want, and you already have all the mechanisms in place. Meaning your application already can live with that the user service might not be there for a moment, or that there might be multiple user services and things like this. And it does not need to, you don't need to change your mindset with the moment you take this step. And this is one of the biggest advantages. So you develop your monolith, and then you can start taking parts out. So which is actually rare for most applications. So in the IoT world, it's something different, but there are all these concepts apply as well.
So okay, this was the general ideas about monolith versus microservices or distributed monolith. So is there any particular support or clouds in OSGI? So is there, because we talk a lot about the services, OSGI services and OSGI modules last time, and we stopped talking about the remoting and whatever. So does OSGI offer something specific to the clouds, or?
I wouldn't really tell specific to a cloud. OCI itself does not care where it's running, if it's bare metal or somewhere in a Docker container or something. What we have though is small recap from last time. We have our modules. The modules communicate via services. These services are as strongly decoupled as possible. Means they know maybe the only connection between two bundles is the service interface, which might be living in a different bundle. And in between, you have the service registry, which acts as a broker. So the framework provides this registry. I, as a service provider, tell the registry, hey, if somebody comes around and wants something with this interface, I have the instance for you. So and then somebody else comes around and says, I need something like the payment provider of this and this type, service registry, please tell me who has this. So this is inside the framework. And you can distribute this system, meaning that we call it the remote service or remote service admin is the name of the specification, which defines a distributed system, meaning that I as a consumer, the only thing I may have in my application as real code is the interface, but no implementation. And another framework running somewhere else in another Kubernetes, Docker, or whatever, bare metal somewhere, just announces sometimes, hey, if somebody comes around and wants the payment provider, I have an implementation for it. So, and then you have this discovery mechanism, which says where everybody knows where any kind of service would be and how to communicate with it. And then you can build some kind of proxy in between, which takes care of the remote communication for you. Mm-hmm. So, and this is something we already have, and which makes it really easy to, yeah, take things out and deploy it somewhere else. And you can even do this at runtime without any restart necessity. So you can have, and you can have a mixture of both. So you have your local services, and there comes a third implementation, which is a remote service, and it just appears in your system. And for the developer, there is no change in the programming model for the whole thing. So, and works like a charm.
And regarding the protocols, does OSGI offer something specific, or are they pluggable? So we can say there is nothing in OSGI, no reference implementation, and you have to plug your protocol of your choice.
That's implementation specific. As the specification itself only describes how the concepts behind it, describes how this discovery mechanism works, which data formats needs to be transferred in this case, and which information need to be available. What the protocol is not defined. It means this is there's, for example, the one implementation is the Eclipse communication framework of Scott Lewis, and he has implementations where he does the discovery over ask me Zookeeper, some messaging protocols, or directly with some I forgot how is it called? Also on with different protocols and the same thing, and in the end the actual remote service communication can be other protocols as well. So via REST, for example, or direct HTTP or WebSocket connections. So, and you can basically combine this, to your heart's content, the whole thing. So if you want to come up with something you like, especially, you can plug in your own mechanism there.
Yeah, I mean, what I thought about was the microprofile REST client, for instance, because this is what you use in the cloud all the time. So, or REST, JAX REST, right? So, because usually it is RESTful. I don't think you will use binary protocols, because usually all the load balancers are working on the application level. And if you have something, would like to have something binary, you would need to use the level 4 load balancers, which are completely different beast. So, so this could work. It would be similar architecture to microprofile. We would just, what we are doing, we are injecting interface, and there is something like a base URI, and the base URI is the DNS name of the load balancer, which is configured at deploy time, which is more or less stable, because the load balancer has an own DNS entry, so it's stable, and you could inject that. So, but I don't think you're doing this very often, right? The remoting, my impression.
It depends. Also for the most business application, this is kind of not really useful.
Exactly.
I rarely had, like you said, usually a monolith, maybe with a second instance for failover and one load balancer in front of it, because everything should be stateless there, is the way to go. Where we use it quite heavily is we have a couple of IoT projects where this comes in really, really handy. Because we have a remote service implementation which uses MQTT underneath as a communication protocol. And we have, for example, one of our demo projects we had, this was that we have a traffic light controller, as meaning so traffic lights and everything. And we have a system which you can install in each traffic controller on the real hardware in your city. And then it will communicate the statuses of which lights are green and red and everything back to a central system. This is done via remote services via MQTT. So we have a central system which basically collects all these remote services which are provided by the individual hardware elements in the field. And yeah, then everything can be shown on a map, and you can do things with the data you get from it in basically real time. And we had a funny situation, and my colleague was developing on her local machine, and she was wondering, with a simulated version of such an such an intersection, and she was looking at her UI and thought, like, where is the thing I've just changed something from? And on the live system or on our development system on the server running, you could see her intersection popping up and going away every time she saved something and did some changes. So because she had the wrong connection settings.
This is why you are traffic jam
environment
now in your city, right?
Yes, yes. No, this is not really. But yeah, things like this can happen. So, but this shows how powerful the system is and how easy it actually works. So,
Mhm.
because you just implementing against services, and the communication in between is taken care of for you if you need it.
This is what I see
And
where actually OSGI should shine on really world devices, because what I suspect is every device is a little bit different. So you can load, or unload the bundles on demand and automatically adapt to the features, right?
yes, that's the one thing that you can take care of all these hardware specific things, and can basically have automatically more or less detect which is necessary, and then install just the bundles that are required there on the specific hardware. There are also systems out there doing that. So you can basically have a small agent running on each hardware you have. If it's a Raspberry or somewhere in the field, it just needs to be a small framework which is running there, and then you can have a mechanism which says, similar to what Kubernetes does. Hey, I have this application. Please put it out in the world. So, and then it goes around, looks like, okay, is my hardware underneath? What does it require? And then pulls by itself the bundles, and populates your infrastructure. Basically, if it's in the field or just your server farm, doesn't really matter. So,
Hmm.
and
One question.
basically that's what basically Kubernetes did later on.
Yeah. Actually, something different. Do you know Romain Manibuco?
You've told me about him, and I still have the podcast you had with him on my plate,
Yeah.
but I haven't
Because
looked
he
into it
started
till
with
now.
Java E, and he goes, he tried Kubernetes, was too expensive, and then he experiments a lot with OSGI, like Kubernetes inside a JVM. So this is our
Mhm.
experience. The last time he changed the company and couldn't talk about that, but it's really interesting stuff he's doing. So it goes to your direction. Regarding OSGI, what interests me right now, let's say we have an update of our live system, and we're
Mhm.
updating from version 1 to 1.1, and then we find out that it doesn't work, so we have to roll back to 1.0 again. Is somewhere like policies, or how to call it, like rolling updates policies, something in place where you can say if this fails, it's like a health check, automatically roll back to 1.0, or is it something like this, or is it application specific? You know what I mean?
This is, yeah, I know what you mean. This is more application specific. It's not really specified how to do it.
Hmm.
We had in the past, we had a server where we did things as we did this rolling updates, and we usually did it like we installed the new software bundles, but just you have the different states. It's just there and installed. Then we basically stopped the old bundles,
Hmm.
started the new bundles, and after everything's checked out, then we uninstalled the old bundles.
Hmm.
So everything had been there. So if things have failed, we could have basically rolled back the whole thing in a short matter of time and restart the old system or the parts of the system that had been renewed. So everything would have been back to.
But you had
But this
load
is
balancer then, right?
something.
You had a load balancer between two systems, or was it in the system inside? So you run two bundle versions at the same time, and the proxy dispatch that. You know what I mean? So if you have a load balancer in
Yeah,
two systems, it's boring. It's not OSGI like. But
yeah. Usually when during this process we basically block this specific node, which is currently had been under update. You can do it with how you described that you have a proxy in between and
Mhm.
multiple versions running, and decide which version to use. So you can do this on the software level. But this, I've tried it out as a, yeah, demo case. But this is in reality, most people don't really do it. They just deploy it as a
yeah,
whole,
this will be
use
more
microcontainer,
exciting. But
because you can do it, but the amount of complexity this adds is rarely worth it.
yeah.
So when you see it over the overall system, like the Netflix stack or things like that, there it would make sense to do it like this. In the old distributed world, but doing this in your one server. So when would you just exchange one class in your war file? So
Yeah.
nobody really.
No,
It's rare that somebody would do
but this is a
something
different
like that.
mindset, I think. OSGI is like the mindset in dynamic and multiple versions of the same bundle at the same time. And the application server is more like nowadays immutable. So there is no no hot deployments. You just rolling forward. So you always, if there is a patch, you ship a new version. This is what happens in all my projects. So I was curious about, the OSGI mindset. And by the way, this is how I killed most of the OSGI projects 15 years ago, because they wanted, to have OSGI. They say, look, we can replace the bundles in a running system. It's like, what if the bundle takes 10 seconds to boot? And they say, yeah, the proxy could take all the transactions and then wait until the other becomes available. It's like, yeah, but under heavy load, forget it. And what happens? You need a rollback, and commit is not that easy. And there was no answers for that back then. And there are still no answers. So the safest is really have a load balancer and have an update in one system. But what OSGI helps us with, the versions are more defined. So if you don't have OSGI, you have to think about, in what is the version of the system. I was at the beginning of microservices. So interestingly, if you have Java E, then this is my application server. Let's say Payara version 5.1 something. Mm-hmm. And if you know this, you can look up which the libraries are inside. And then in my war, I just said I would like to have Java 8, and there were no dependencies. So what it means, if we build microservices with Java E, we exactly knew what runs in production. If there was a security patch, it was very easy to identify which runtimes were active right now. With FedJars and UberJars projects, they had no idea what's running in production, because they used to know their own runtime. Everything was created in a UberJar back then. This jar was started in production, and there was no list of dependencies. So if there was a security issue, no one knew what's running in production. So now with Quarkus and Micronaut, this is similar. So at least if I know the version of Quarkus, I know all the dependencies. I have to be a little bit careful, because I can do more in my POM. So what Quarkus, Micronaut, or Helidon, what they are doing is not like you're saying, I have one dependencies microprofile. You have to add, small y 10 dependencies, and this is your microprofile set. But it's still somehow defined. But what I usually do, I also couple it with commit ID or whatever. But in OSGI case, it's even better, because per definition, at least if you have a monolithic OSGI deployment, just one huge bundle, this bundle has to have a version per definition, right? So it's easier to know what are my dependencies in productions. If there's a log4j or whatever issue, it should be very easy to identify what actually is. And the follow-up question is, can I ask the OSGI runtime give me please a list, or the registry or whoever, list of all the dependencies with versions? This would be helpful in production.
Yes. You can do this at runtime. You can always see what bundles are there. So that's the first thing.
But how you can see? Is it like a call, a REST call, or
you can introspect programmatically the framework, or we have the most common case is the Google console. So you have like a shell you can interact with. You can connect to it remotely if you want. Or there's also the so-called web console, which is just a web interface.
But what I would expect
inside your bundle,
that the service registry is a standard OSGI, right?
Yes.
So then there is a method, give me all registered bundles. And this method returns the bundles with versions. And then, web console or shell or REST is like adapters to this, functionality.
Exactly. So this is what it is. So they all use the same mechanisms underneath.
Yeah,
so
but there is a defined mechanism for it, right?
Versions.
You have a standard API.
Yes, definitely.
Okay, this is what I want to hear, because of course.
And you can even go. Sorry to interrupt you. You can even go a bit further, and this is what really comes in handy. You can ask the system at runtime which bundle and which package is provided in which version and who's used by whom.
Exactly.
So you can exactly see who is connected to. Somebody is providing a package ABC, and you can exactly see who is using this package in this version at this moment.
Yeah.
So and you And this is really helpful. And on the other hand, you can add development time or at build time. You have how we usually, also you have different. You can have something like Carafe, where you have batteries included, OCI environment where you can deploy things in. We usually go a different route. We write for example, our REST bundle, and then you have the so-called resolver. I believe I briefly talked about previously, where you can say, hey, I have this bundle here. Please give me everything which is required to run this bundle or this set of bundles which comprise my application. So and then the resolver comes around, looks at the contracts and says, okay, we need a web server, so we pull in a Jetty. We need A, B, C, D, JPA, and whatever you're using in there, and returns a list of, okay, these are all the bundles that you require in order to run your application. And you get a quite comprehensive view on why it is pulling these things in. And you can look at this list and can ask this list, okay, why are you using this specific bundle? And it will tell you, okay, I use this because somebody asked for this, then this came out of this, and somebody asked for this because of, and you get all the informations why things are in there, which is really helpful when you try to find out why the hell some dependency is in your system.
Yeah, this is what I'm interested in. No, what I'm interested is not what the runtime is able to do. What is the standard? Because if we have a standard method, we can always expose it via JAX-RS or whatever. Have you JMX or I don't care. So yeah, but this is what you could do with it is every morning you can look at the public CVE database, watch the dependencies, then ask your runtime, do we have this dependency, or other way around, ask your runtime first, give me the list of all external dependencies, then go to the CVE database and say, okay, do we have a problem or not? And if we have a problem with OSGI, I could actually create a report. We need to patch exactly these bundles, and whether you patch the entire thing or just the bundle is up to you. But this is the the first killer feature today of OSGI, right? So it's really true because, for instance, in my world, such a thing is indirectly available, right? I have to know which Quarkus version I have or Micronaut version there is. Then I can look up, okay, if I have this version, then this micro profile is used and this external implementation is used. So I can find it out indirectly. But in OSGI case, I could actually at any time in real time, I can check what is actually in production.
Which actually a really good idea. I never thought about it.
And then
I believe we should implement something like this.
And compliance. So this is getting more and more. I'm more and more in projects which are somehow problematic from security perspective and stuff like that. So for compliance reasons, for audits, you can say, look, this is what we have in production. This is the true list of dependencies, and this is like it is. There's no way around. So for the other runtimes, it is harder to tell what's in production, right?
Yeah.
Another thing.
And you can actually even fix this and say, hey, if somebody comes around and tries to put in malicious code or something like this, always check that my bundles have exactly the signature that I told the system before that they should have, and things like
exactly.
This. So,
and another thing is, which I don't know whether you are aware of, there are services on AWS like AWS Config. What they are doing, they are constantly monitoring whether your system is in desired state. So what you can do as OSGI exactly the same. We can say, okay, I don't want to have, let's say, Lombok in my project, right? So you can say if someone deploys that, you will find it out because without code review, because you can ask at runtime with a small plugin and say, okay, Lombok is actually not a part of our policy or whatever. Don't use it. Or Log4j with critical version, maybe more fair example or something like this, right? So another thing to have to draw the parallels to the cloud is in Kubernetes and OpenShift and Fargate and whatever, what we use a lot always is infrastructure as code, IAC. So, and there are great tools like, let's say, Pulumi, Terraform, or CDK or CloudFormation. And how they look like, you have the desired state on your machine, and the state is synchronized with the cloud APIs, right? So, yes, so recently Pulumi support for Java came out for the clouds, but I'm talking here about clouds, OpenShift, like whatever has an API. We already found out that OSGI has a service API, which is standard. So what you could actually do is you could consider your OSGI runtime as a Kubernetes runtime. And they say, okay, this is like Kubernetes, but it's called OSGI. And now I could have, my resources defined as Pulumi or Terraform resources, and say, okay, I would like to have this bundle in this version and expose via this thing, and you have the state they defined this in a description outside, and then your environment would look like this, one load balancer, two OSGI runtimes with all the dependencies. This is what I missed in application servers. What I wanted to have back then, there was deployment API, and this deployment API was deprecated, but it happened 10 years ago. My idea was, to have an application server running, and then we have CI/CD pipeline with Jenkins, and we could automatically configure the application from outside the server.
Yeah.
I didn't want it to fiddle, with the XML and all the deployment descriptors. I wanted to say, look, an application server was for me like a cloud. Like, just imagine data source to a database, right? So I could say, in order to make it run my application, I would like, 10 connections to the database with username, password, its credentials, and so forth. And this was my idea, that there is some standardized API to all application servers, and I can just provision them and then deploy my app. But you could actually do it, right, with OSGI.
Yeah, we can. So, and there are systems out there that do exactly this.
Yeah, but
so you can.
Yeah, I know.
We have a new and yeah. This there's also we have now a specification called a feature. There are features around for ages. So which is kind of my overall deployment descriptor, and this is a combination of all these things. Like, okay, I can tell it these are my bundles I want to have in there, and these are my configurations I want to have in there as well. So this is my database connection, or you can configure whatever you like, and then the system tries to resolve what's not in there against the repositories you tell it. So you only need to write in there the things you definitely need. You don't have to define the whole, and the system will take care of the rest, basically, and launch and install these things. And you can also distribute them to different systems.
I don't know about this feature.
By the way, just a minor thing, if somebody's interested, and also if you're interested, because of the introspection of the system, there is a project called, also if you go on osgi.fx, they have a few screenshots on how such an introspection of the system could look like. So it's a JavaFX application which introspects your OSGI framework via some kind of agent. And this is what you can get out of it. So you see the connections, who is using what, which services are there, and all these things. So if somebody's interested
OSGI.fx.
in having something,
put me to the chat. I will put it also to the show notes. But I mean, the visual thing is interesting, but the automation will be the killer feature. You can sell, in the CI/CD, a commercial product which says before I'm shipping, there are the rules, and we know exactly what's inside, and this is, the report. And if there's a violation, and you can, of course, in real time ask, the CV database or whatever, because this is where OSGI shines, and this is what the others are not as good. So, and of course, OSGI FX looks nice. But the others would be more. I think the future is in automation, or future it already is. So whatever I do, I try to automate, and not necessarily because it's easy or whatever, but it's repeatable and this is documented. That's the cool stuff,
Yeah.
And what I do a lot, it is a completely different topic right now, but I have to work with clouds. And for instance, in AWS, there is a CDK cloud development kit, and you can use Java to describe the cloud. And this has great success among Java developers because, they define this. It looks like, you say, let's say, bucket.builder.create, and you can specify is it public or not with permissions or function or whatever. And actually, you could do the same with OSGI. That you write a Java code to describe your environment, and then you have, the environment is there, and then you can ship your bundles. So whatever we talk now,
yes,
yeah, and because then OSGI becomes the cloud.
Yeah, that's the funny thing. What all of the things you describe are out there quite for some time. There are a couple of companies that tried to establish such systems. They lost against Kubernetes in the end, and things like this. Because of missing popularity and not that much money behind the whole thing. But all these things are possible for ages, basically, with OSGI. And this is uh, one of the contentious areas. We basically OCI invented the service driven development 25 years ago, and then SOA came around and
Oh,
coined
but I
the
don't think
phrase
it was
service oriented for
OGI,
themselves.
Jürgen. Also, you have Taekwondo then too, but now I am no more. I am not afraid of you
And
because
it's not that they invented the concept. This is not
Genie,
what I'm
Java
saying, but
Intelligent Network Infrastructure was before, I guess.
there might be something before, but usually with the OCI had been the first system which really had been capable of doing these things in a comprehensive manner. Maybe not the perfect one, and maybe not the first one, but it's usually somebody came around and took the word from us. So later,
Yeah,
microservices came by Martin Fowler and with his definition, and there had been a huge discussion around the thing.
because
Hey,
I
this is basically
I
we
can
call it
tell you why.
microservice.
By the way, I'm no more afraid of you because you told me your Taekwondo is more like yoga. You cannot hit me, so now I can speak against you.
I can tickle your nose with my feet if it
Yeah, okay.
push comes to shove. Where you're standing.
Genie. Genie was the great technology ever. I was a huge proponent. Java Intelligent Network Infrastructure. You have to look at this. I still stealing ideas from Genie in my projects. So I tell you how Genie. You know Genie?
It rings a bell, but
Yeah,
I
Java
have
Intelligent
to
Network
admit,
Infrastructure. Yeah, and there's Apache River project was the open source version. Just to briefly, what they did, it was genius. You publish a Java interface, and it became visible in Genie registry, and whatever you did, you had to publish. Now, in order to remain in the registry, you had to republish it over and over again every 2 seconds. What means if the service was killed, it automatically disappeared from the registry, and this was called leasing. So you had to lease a service. If you wanted to have a service from the other side, you also had to lease the service, and if you forgot to lease it, right? So it became unavailable for you. So we had something like distributed garbage collection out of the box, and this was in 1999. Now, then you can ask the registry, give me please, the interface. Okay, back then you got RMI, proxy, and you could call, the service. It was like SOA before SOA. The problem was Sun was not capable to sell this. And I was at conferences back then, and they promoted this as a way to distribute printer drivers or something crazy stuff. I mean, no one wanted to have that. Or they had, at the conference, they have a codec cameras back then, which say, okay, the drivers are distributed with Genie. It's like, who cares about that? But this was way before SOA and before Java EE. But I still use, the ideas in my project. There was a Java Spaces implementation, which is basically a distributed hash map with transactions. And this was in place. So, and then OSGI came 2 years later. This was to my thing. And why OSGI was not successful? Because it came too late. This was the problem. So in my projects, I had the wars in Java East and everything. We had already the services, and I remember back then, WebLogic. They was before Oracle bought them. I think they said, okay, now we are going to use service framework from OSGI internally. And we could use OSGI, but it's like, why we should use OSGI? We have already wars. So we had two competing technologies in one runtime. This was the problem. And of course, the vendors, they used OSGI internally. But for me, why I should use OSGI, right? I was happy with the war. I had my monolith, and I was very happy in production. But let's say now, we say if the problem is, that the teams have to work in isolation, then OSGI becomes the solution again, and with no additional features like policies and audits and infrastructure as code, it becomes maybe relevant again. Not only relevant, it becomes the killer feature, because I don't know whether the Python dependency management and Node dependency management is not as great as Java. So we have to. It is like it is, right? Yeah. And with the ability to tell me, which is really in production. This is like, highly secure environment, I would say. And which you could even assume it would be easy also to lock down all the dependencies, right? You can say, I only allow this exact dependency graph and nothing else.
Yeah, this is. We basically came full circle now, because I believe in our first
the last thing, because why it was not successful. What I think what you should change the strategy is, if you pick infrastructure as code, I will pick Pulumi because very modern, or Terraform, and just write the providers for it. I don't think if you introduce another tool, it is going to be accepted in the community. But if you write a plugin to an existing tool, this is what I just wanted to sorry for the interruption.
That's what we, yeah. Okay, so first off, regarding the history, so it was well before my time, so I can't really tell anything to this. But a lot of what I've just looked it up while you've been talking. Genie, it rings a bell, and I believe a lot of these concepts also found their way into what we do in OSGI. But I can't speak to that. I haven't been around.
Yeah, you have to look it up.
So
search for Genie and leasing and Apache River. You will like it.
Yeah, and as you described the process, as you described the whole concept, it rang a bell, and somebody told me already about it. So I believe it was somebody from the OSGI line, but that's water down the river. But what I realized, we basically came just full circle, because as in our first chat we had, do you remember that I started by, okay, we already have dependency management in with Maven, but and OCI is dependency management at runtime, and this is what you actually described now. So this audit functions and everything is there. But yeah, the other thing which you said with connectors to Terraform, this is something we'd love to work on. So OCI itself is just a standard which should be technology agnostic as much as possible, but doing things like this would be great. We unfortunately, as my company, don't really have the time to get into all these things.
No,
so I'd love to do R&D all day long to
no, but how does usually works? This were my questions before. How does usually works? Pulumi or Terraform? And Pulumi, by the way, they released recently. You have to listen to the last podcast with the CEO, with the founder of Pulumi. They have full Java support right now, which is great. And it's called Pulumi, and Terraform is also great, but it's older. It's like already 12 years old. But how they are working is they're calling REST interfaces. So this was my question. So if you expose OSGI via REST, then you can write the resources around that. And basically how this would look like someone would, locally invoke your OSGI service definitions via Terraform. And what the Pulumi and Terraforms are doing, you are just specify, I would like to have, 2 nodes in production. And it reconciliates the state between your state, your desired state, and the actual state. It's not like they're calling the API. You are defining, I would like to have 2 nodes in production, and they are monitoring that, and if you change in the OSGI console to 3 and run, Pulumi or Terraform again, you will find 2 again. So it's not like they are calling the API. It is not imperative, it is declarative, which makes a huge difference.
Okay, so you declare your...
Yeah.
And sorry, you've lost me somehow. I have to admit.
For instance, the difference is, let's, S3 bucket, right? This is just a folder in the cloud. Very simple.
Yeah.
So if you do it imperatively, you would call the Amazon SDK and say, I need an S3 bucket. But because the bucket has to be with a new unique name, you can only do it once. The other ones, you will have to write a code like, is the bucket already there? If, then do it, otherwise not. Now, if someone depends on your bucket, let's say this is your Docker registry, actually needs the bucket under the hood, but let's assume you will have to do it. Then you have to create, I create the bucket first. If the bucket exists, then I can create a Docker registry. And if the Docker registry is already, you will need already 2 if-else, which gets crazy complex. Terraform and Pulumi, you just say, I need a bucket and I need a Docker registry. This is. And they store the state like, JPA state for you. This is very similar to JPA in the cloud. And then if someone changes the state, they say, okay, we need, let's say you rename the bucket. Then they look at the state and say, okay, in order to rename the bucket, I will have to destroy it and recreate it, or they know, no, I only have to change the name. It depends on the resource. So you have in your declaration in Terraform or Pulumi, in Terraform is like, it's not Java. In Pulumi, the cool story is actually Java. So you have your bucket with your name, and if you change the name, it looks, okay, my name changed locally, but in the cloud, there's still the old name. So they know, okay, then I will call the cloud and just rename the bucket.
Okay, yes.
Yeah, you know, so you're not programming what to do to achieve that. You only declare the desired state. Or simpler, in our world, data source, right? If you have a data source with Terraform or Pulumi, you could say the amount of connection is 10, right? Just this. And then you would like to have 20. Then it looks 20 occur in the cloud at 10. Then it goes to the cloud and just changes the data source from 20 to 10. Yeah. But because it knows, okay, but in Whitefly, I will have to restart the Whitefly, I will also restart the Whitefly because it knows already. So this is actually this is how it works. But if it wouldn't be declarative, imperative, then you will have to code it, right? So it's okay.
Okay, now I get it. Yes.
Yeah, this would be terrible. Yeah. So if the data source is there, then I can change it. If it's not there, I create it first and then change it. So it would be crazy complex. Forget it. And this is the declarative thing. And I think you can plug your service mechanism to Pulumi. It's pure Java, let's say. Or it only makes sense in Pulumi. Terraform, they have own language. You could also do this. And then you will have to call your remote interfaces. This is the only thing you have to do. And Pulumi or Terraform care about the state.
Yes, this seems totally feasible.
I don't know how it should be more popular than any attempt to do it by yourself, because you will fail. There's a lot too complex.
Yeah, I think so as well. So I usually, when I look what everybody is doing with Kubernetes and with all these different approaches to configuring your complex systems, I often have the feeling that the same people are turning on their heels when you describe OSGI, which does exactly that, and say, no, OSGI is shit. So, and I ask myself, why? Because it's doing the same things. You can use it to achieve your goals, and you have already a lot of the kinks worked out of the system, and you can you can just plug it in what you are already doing. So, and we also realized, so the first attempts of doing what Kubernetes and things and everything does was like having OSGI underneath it and let it control the environment. Now I think, okay, we now have all these different tools that are there and that are there to stay. Why not try to plug it in and make it part of the overall system?
Yeah, I think we had already this discussion with Bruno Borges, and Bruno told me he's he's an Asia manager or a Java manager at Microsoft, and told me, okay, we have to keep development excited about the thing. So I think the problem is developers are chasing new buzzwords and not necessary solutions. Yeah. And OSGI had really, I was absolutely not interested in OSGI because it didn't solve none of my problems back then. Now with your listing all the dependencies, I could see, okay, there are some killer use cases which could be helpful in critical projects. And before I do Kubernetes, I do OSGI, right? So this is like for me.
I applaud from my side.
Yeah, and now you understand also why I'm not that interested in Kubernetes, because with the declarative stuff I told you, if you provision the cloud, we would provision first the cloud, and then we will have to provision Kubernetes. So there are actually two stages. And the Kubernetes is like entire cloud inside, so they do everything inside, right? So, for instance, on Amazon, there is a CDK, Cloud Development Kit, what we talk about is very similar to Terraform. But for AWS, for the cloud, and there's one CDK for Kubernetes. So I actually will have to use one CDK to provision my networking, whatever, and the other one for Kubernetes, which for me is, okay, this is pointless. Why I should do this, right? I mean, this is like defeats the purpose. But with OSGI, I could see this because I could provision not Kubernetes rather than Fargate, which is just 2 Docker containers. And then with OSGI, I can say, okay, this is the runtime environment for the OSGI. And then I can use another resource to provision my OSGI runtime, and with all the dependencies, whatever makes sense. And this should work actually fine after the discussion today.
Yeah, I think so too. So I really love working on this, but that's unfortunately too many other projects.
No, it's just ideas. Just ideas. And for me, it's all
but I love this idea. So we basically floated some of these ideas around ourselves, but I haven't really gotten around really doing it, and I don't know of other people that are actually doing it. So
You have contact
we are
Romain
working
Manibuko. I think he's
yeah,
also
I
working.
definitely have to, because we are having some things in place already which might help along this road, and we need to find a volunteer army to drive these ideas.
Perfect. It was great discussion. I'm out of my
Yeah.
ideas. So, where people can find you on the internet, and also if someone in the listeners has a higher Dan than yours, this is Dan, right? This is the Taekwondo also has Dans? No.
Dan, yeah.
Oh,
Yes.
Dan. Okay. If someone has the
Dan,
fourth
yeah, it's,
Dan, he could challenge you that you get also your fourth Dan, right? No.
your third in my case, because I have the second
Ah,
Dan,
we
and
need
I
someone
want
from
to
the
graduate
listenership
to the
with the third Dan who could challenge you.
No, I already have people, but before I could do it, then Corona hit, and all the on-site events where I would have got the chance had been cancelled, and now I have to basically get back into
So
the
the
game.
AXFM listenership cannot help you with your dance, but at
No,
least
they don't. They don't have to.
at least infrastructure as
But,
code, you know.
Yes, their help is welcome, and all the ideas. So, and also, I'd like to use the chance for some marketing here. If somebody is interested in the ideas behind the OCI, we are now a working group. Means we are an open source project. Everybody can join. We have the technology project where we discuss the specifications. This is open for everybody to attend the meetings. We meet every 2 weeks. Also, this year the EclipseCon is again in Ludwigsburg, where is an on-site meeting, so you can find us there. Please contact us. We are a volunteer army. Everybody's welcome. Please join us.
What
in some way, shape, or form.
Attendee, how to call it, how to contributors can expect. So if I would join your Eclipse OSJ effort, they can work on proof of concepts or on the spec, or what they can do.
We have a couple of fields that where we need support. So one thing is the basic purpose is specification writing. So if you have ideas for specifying things, this is where you would need to do it. Also, if you want to provide implementations or tooling for different things, working with OCI, we have this OCI technology project, which can be a home for things like this, and you would get the support of the experts, I would call it. So the people who know what's what and how things can be done. And also, if you are just a fan of OCI and like to see it flourish more, then we also need help in community building. So we are at the moment a relatively small group, and the more people, the better it gets.
So you will send me the links. I'll put in the show notes. If someone's interested, can just click on the link, and we'll work with you on infrastructure code and all the great stuff we discuss here in the podcast.
Yeah, definitely. I'm looking forward to
seeing
new faces.
Thank you. See you next time.
Okay, thank you.